Okay, so for this question, let us read the question first and try to visualize how this circuit looks like. So a power supply of electromotive force 12, which is drawn here, okay, is connected to an internal resistance of 2 ohms and also connected to a load resistor that can be varied from 0.5 to 4 ohms. Yeah, so if I draw the circuit, it will look like this. And I also symbolize the load resistor as RL. And the question is asking which graph shows the power P dissipated in the load resistor as the resistance is varied from 0.5 to 4. So again, because the question is specific to find the power of the load resistance, that means we need to find the values that we need to find power. So it's either we find voltage, right, with resistance, which is already given, or we can use current and resistance, which is also already given. Sorry, I forgot to put L here. And you can use either of these three formulas. So it's either you use V squared over R, I squared R, or IV. Yeah. And I think looking at the circuit, because it's a series circuit, I think the simplest formula or the simplest approach will be to use this formula, because we know that IRL, or the current of the load resistor, is the same current as the entire circuit, because it's a series circuit and current is the same everywhere, right? So I think that's the simplest approach to this question. So what I'm going to do is I'm going to find, remember, yeah, I want to use this formula. That means if I want to use this formula, I need to find what is IRL, right? And I will multiply it with the value of resistor, which is already given. It's either 0.5 or 4. So now I'm going to find IRL when the load resistance is 0.5. Yeah, and I know that this current IRL will be the same as the source current, IS, because it's a series circuit. So that means to find the source current, or to find the current in the resistance load, right, in the load resistance, we just need to find V over total R, right? Total voltage over total resistance, because it's a series circuit. So that means I know my voltage is 12, and I know my total resistance is 2 plus 0.5. Oh no, my cat is crossing. Okay, so it's 2 plus 0.5. And then we will find our current to be, give me 1 second, 12 divided by 2.5, just need to be sure, 4.8 ampere. So that means when the resistance is 0.5, I know that my current flowing through the circuit and flowing through load R is also 4.8. So that means the power is I square R, which is 4.8 square, times the R that we're using now is 0.5. So I think the value is 11.52. So 11.52 watts. And then the second step that we need to do is to find out what is the current in the circuit, or the current that goes through the load resistor, when the load resistance is 4 ampere. So let's do the same thing. It's V over R, which is 12 divided by 2 plus 4. That is 2 ampere. So when the load resistance is 4 ohms, the current that is flowing through is 2 ampere. Then we can find the power. The power is I square times R, which is 2 square times the resistance now that we're using is 4. So our answer will be 16 watts. And then let's look at the graph. Which graph represents this best? So definitely when the resistance is 0.5, the value is not 0, so it cannot be C or D. And then when the value of resistance is 4, we know that the value of power is 16. So it's higher than when it was 0.5 ohm, right? So the best graph that represents this is A. I hope that is clear. Oops.